Today we're going to look at double angle identities. The double angle identities come from using the sum formula that we studied in section 5.3. If we look at the sine of 2u, that means we're doubling angle u. This comes from taking the sine of u plus u. If we apply the formula that we learned last chapter, then we get that the sine of u plus u is the sine of u times the cosine of u plus the sine of u cosine of u. Therefore, the two terms are identical, and we get 2 sine u cosine u. If you ever need to simplify a double angle, sine 2u, you will replace it with the formula we just derived, 2 sine u cosine u. If we look at the cosine of 2u, we again apply the sum formula for cosine. Cosine 2u is cosine of angle u plus angle u. Applying the formula from section 5.3, we get cosine of the first times cosine of the second, which in this case are the same angle, minus sine of the first, sine of the second. Multiplying, we can see cosine u times cosine u is cosine squared u, minus sine squared u. This is one formula for cosine of 2u. There are two other formulas for cosine 2u. Cosine 2u is also equal to 1 minus 2 sine squared u. And cosine 2u is also equal to 2 cosine squared u minus 1. The second two formulas I just showed you, you will derive them using the cosine of u plus u in your homework assignment. Try and follow the example above if you get confused. The last double angle formula is tangent of 2u, which is equal to the tangent, again, of u plus u. Applying the tangent formula, we get tangent of the first, tangent of u, added to tangent of the second, tangent of u, divided by 1 minus the tangent of the first, tangent u, times the tangent of the second, tangent u. Simplifying the numerator, tangent u plus tangent u is 2 tangent of u over 1 minus tangent u times tangent u is the tangent squared of u. This is the formula for the tangent of 2u. Now we're going to use the double angle formulas to help us prove an identity. If you look at the equation, cosine 6u is equal to 2 cosine squared 3u minus 1. Remember, in an identity, you must start on one side and show every step on how you get to the second side. I am going to start on the left side with cosine of 6u. When I look at the right-hand side of the equation, I see that the angle is 3u. Therefore, I can think of this as a double angle. So cosine 6u can be thought of as the cosine of 2 times 3u. 2 times 3u is equivalent to 6u. Now, if I apply the second double angle formula, then I can make the substitution and get the right-hand side. This becomes 2 cosine squared of the angle, which in this case is 3u, minus 1. And I have just shown that cosine 6u equals 2 cosine squared 3u minus 1. We're going to prove another identity. We need to prove that 2 cotangent 2x is equal to cotangent x minus tangent x. Again, I'm going to start on the left-hand side with 2 cotangent 2x. Now, there's no double angle for cotangent 2x, but we all know that cotangent of 2x is equal to 1 over the tangent of 2x. So we're going to get 2 divided by the tangent of 2x. Now, we're going to apply the double angle formula for the tangent of 2x and substitute it. So we have 2 large fraction bar, and the tangent of 2x is equal to 2 tangent of single x divided by 1 minus the tangent squared of x. Now we're going to copy dot flip. So the 2 becomes the fraction, 2 over 1, and we multiply by the reciprocal, which is 1 minus tangent squared x over 2 tangent x. You can cross cancel the 2's, and multiplying across you have 1 minus tangent squared x over tangent of x. You're almost there. You can break the 1 fraction into 2. So you get 1 over tangent x minus tangent squared x over tangent x. And we all know that 1 over tangent x is equal to the cotangent of x minus the tangent on the bottom cancels the square, and you get tangent of x. And you have just proven that the left side of this identity can be turned into the right side. In the next example, we're going to see how a double angle can play into a trig equation. We need to solve the sine of 2x equals cosine of x. Because the two trig functions have different angles, it is difficult to solve. If we use the substitution for sine of 2x, it is equal to 2 sine of x cosine of x. This now puts the equation all in angle x. Now, from here we need to use our equation solving skills. We're going to subtract the cosine of x to the left side. We get 2 sine x cosine x minus cosine x equals 0. In order to solve this, we can factor out the GCF, which is cosine x. Taking the cosine x out, we have 2 sine of x minus 1 equals 0. Using the zero product property, set each piece to 0. Cosine x equals 0. 2 sine x minus 1 equals 0. Let's finish solving the equation on the right-hand side. By adding 1 and dividing by 2, we get that the sine of x is equal to 1/2. Going back to the left side, cosine of x has to equal 0. Cosine is the x-coordinate, therefore the x-coordinate would equal 0 at x is equal to pi over 2 and 3 pi over 2. Now, looking at the equation on the right, you need to use your reference triangle. So if we draw our reference triangle, angle 30, angle 60, side 1, root 3, and 2. So which angle gives a sine of 1/2? That would be 30 degrees, which is pi over 6 in quadrant 1, where sine is positive, and then we need to give the second answer in quadrant 2, which is 5 pi over 6. In this example, we again want to solve for x. If you look at the left-hand side, you notice you have a double angle, cosine 2x. There are 3 possible substitutions for cosine of 2x. You need to determine which one should be used here. When I look at the right-hand side of the equation, I see a cosine x. I know that an equation is simpler to solve if it's all in one trig function. Therefore, I'm going to substitute the left-hand side with the formula that requires only cosine. So cosine of 2x is going to be replaced with 2 cosine squared x minus 1. This is equal then to the cosine of x. If I subtract the cosine of x to the left side and put the pieces in descending order, I get 2 cosine squared x minus cosine x minus 1 equals 0. This now looks like a trinomial. It's quadratic in nature and can be factored. Factoring, you get 2 cosine x times a cosine x equals 0. Products of 1 are 1 and 1. I need a negative in the middle, which means I need the 2 to carry with the negative sign. So we're going to go negative here and positive here. Now, setting each piece to 0, we get 2 cosine x plus 1 equals 0, and we get cosine x minus 1 equals 0. Solving the one on the left, you subtract 1, divide by 2, so cosine of x equals negative 1/2. Adding 1 here, you get cosine of x is equal to 1. Let's finish solving this one on the right first. Where is cosine equal to 1? That's at an angle of 0. Now I need to figure out where cosine equals negative 1/2. Using my reference triangle, again, here's 30, 60, 1, root 3, and 2. Cosine is equal to 1/2 at 60 degrees. Cosine is negative in quadrants 2 and 3. So my answers are 60-degree angles that occur in quadrant 2 and 3. So x would equal 2 pi over 3 in quadrant 2 and 4 pi over 3 in quadrant 3. So this equation has 3 solutions. In trigonometry, we also have what are called half-angle identities. These identities allow us to find the exact value of angles other than 30, 45, and 60. You do not need to memorize these formulas. They will be given to you on any test or quiz that we have. I am not going to derive these formulas for you either. All I'm going to do is show you how to use the formula. The first example is cosine of 105 degrees. Now, 105 is our u over 2 angle. So we have to decide, first of all, if we're going to use the plus or the minus sign. Since 105 falls in quadrant 2, cosine is negative in quadrant 2. So we will need the negative sign. Applying the formula, we get 1 minus the cosine of u. Therefore, you must double the angle 105 because that is u over 2. So you get 1 plus cosine 210 degrees divided by 2. You then need to use your reference triangle to find the cosine of 210 degrees. 210 is a multiple of 30. So we need the cosine of 30 degrees, which is root 3 over 2. Now, the cosine in quadrant 3, because that's where angle 210 is negative. So we get negative square root of 1 plus negative root 3 over 2, all divided by 2. There's the formula. Now you have some algebra to do to simplify this answer. The negative out front stays. We're going to write 1 as 2 over 2 so that we can add the numerator of this fraction together. So we have 2 over 2 plus negative root 3 over 2 all over 2. Adding the top together, we get negative root 2 minus root 3 over 2 divided by 2. When you divide by 2, it's the same thing as multiplying by 1/2. So we get negative root 2 minus root 3 over 2 times 1/2. All of this is still underneath the root. Multiplying together, you see that the denominator becomes 4, and the square root of 4 is 2. Therefore, the final answer is negative root 2 minus root 3 all over 2. That is the exact value for cosine of 105 using the half angle formula. In the next example, we're going to find the sine of pi over 8. Pi over 8 is our u over 2 angle. Pi over 8 is half of pi over 4, which is 45 degrees. So the sine of pi over 8 is actually the sine of 22.5 degrees. Applying the formula, we get the square root of 1 minus the cosine of angle u. Again, pi over 8 is u over 2. So doubling that, you get pi over 4 in the formula, divided by 2. Using your reference triangle, the cosine of pi over 4, which is cosine of 45 degrees, is root 2 over 2. So you get 1 minus root 2 over 2 divided by 2. At this point, again, it's all algebra. If we let the 1 be written as 2 over 2 to create the common denominator, we get this. Putting the numerator together, you end up with 2 minus root 2 over 2 divided by 2. Dividing by 2 is multiplying by 1/2. So this gives you the root of 2 minus root 2 over 4. We can square root the 4, so the final answer becomes the square root of 2 minus root 2 all over 2. And that is the exact value for the sine of a 22.5 degree angle. Our last example is the tangent of 165 degrees. There are 3 formulas for the tangent of u over 2. I often stay away from the first formula with the large square root and the fractions underneath. I'm going to use the second formula on this problem. The formula says that the tangent of u over 2 equals 1 minus the cosine of angle u divided by the sine of u. So we get 1 minus the cosine angle u, you have to take 165 and times by 2, which is 330 degrees, divided by the sine of 330 degrees. 330 is a multiple of 30, so we need to use our reference triangle to find the sine and cosine. So here's 30, 60, 1, root 3, and 2. Back to the formula. We get 1 minus. I need the cosine of 330, so I need the cosine of 30, which is root 3 over 2. And in quadrant 4, cosine is positive, so this will just be root 3 over 2. Divided by the sine of 330. The sine of 30 is 1/2, and in quadrant 4 it's negative. So we get negative 1/2 on the bottom. Now, getting a common denominator on top, the 1 is 2 over 2, so we end up with 2 minus root 3 over 2 divided by negative 1/2. If you copy dot flip, you then get 2 minus root 3 over 2 times negative 2 over 1. The 2's will cross cancel, and therefore you just have to multiply the numerator by negative 1, which will give you negative 2 plus root 3. And that is the exact value for the tangent of 165.